Hello everyone, it's June 26th. Alright, let's do this easy question. Find center of star graph. There is an undirected star graph consisting of n nodes, labeled from 1 to n. A star graph is a graph where there is one center node and exactly n minus 1 edges that connect the center node with every other node. You're given a 2D integer array. Edges where we have an edge indicate that there is an edge. Return the center of the edge. So we just need to find the one that everybody else has. So yeah. Okay, so now we have this opportunity. I think it's time for us to investigate all the other problems that we have been lacking. At least one problem I think we can solve again, which is using a prefix sum, not prefix, yeah, monotonic array to keep track of the biggest and smallest. All right, so what we're gonna do? So we are going to only need to check both, right, to see if anyone is okay. So what we can do is okay, we need to know the API. I actually don't know. Java array includes. No, I don't want that. I want this. Is that one of them say at the end of the day you'll have to do a loop anyway? Yeah. Yeah, you'll have to do it anyway. Okay, so that's fine. So what I'm gonna do is basically if edges, wait, hold on. Edges at least have 2, right? Edges length n minus 1. Edges at least have 2. So I can say edges 1, 0. If it's equal to edges 0, 0, we return edges 1, 0. Right? Else, if it does not equal, then it could be either 1, right? So if the 0, 0 equal, if it's not equal, so if edges 1 is equal to the other one, yeah, I just says or edges 1, 0 is equal to edges 0, 1, right? So we have matching this match this match this. If neither matches, which means the current cannot be, so then we can return edges 1, 1. Looks about right. 1791. Mind twister. Okay, so we're done with this. Now we can move on. Greedy. It's called as greedy. That was funny. Okay, so now we can do this. Alright, so I don't remember when was this. I think I'm gonna just do it in Python, you know, just for fun. $14.38, right? $14.38. So we will use monotonic increasing array to keep track of the min of the current sliding window, and monotonic decreasing array for the max. So we can say mon inc mon dec. Okay, so I'm increasing, decreasing, and then we'll go through this, right? Each time we'll add something to that. So we can say for n in nums, have rest equal to 0. And then we'll handle the, so we'll say while monotonic increasing and monotonic increasing -1 is, because I want it to be increasing, which means if the current is the end is bigger, right? If it's bigger or equal to n, we say mon increase dot pop, right? Well, pop until we find something smaller, and then we'll say monotonic increasing dot append n. Okay, so I want to do one. While monotonic decreasing and monotonic decreasing -1 is smaller or equal to n, right? And it's bigger, so we'll pop. Pop. And monotonic decreasing dot append. And okay, so after we handle this, we have the current max and current min, right? Current max and current min, and all we need to do is, oh, we also need, yeah, we need a left and right. So we have a low, okay, and high, right? Okay, so now we need to do is we have a low and a high, and then we need to check to see if the current, we say, so we need to pop the left, right, until the minimum is gone, right? It's the minimum. Oh, we need to pop left. Dude, we need to have deck. This has to be deck. Maybe make it automatic do deck. Alright, this has to be a deck. Okay. And then we say while monotonic increase, monotonic decreasing, right? 0 minus monotonic increasing 0. If it's larger than limit, then somebody needs to be popped, right? Somebody needs to be popped. And how do we check? We check the left, right? We check left, and we say if nums low, okay, equal to monotonic decreasing 0, then low plus equal, then monotonic decreasing dot pop left. Okay. If nums, do we only pop one of them? Or is it possible we pop both? Yeah, because we hit. I don't think I think all the equal ones need to be kept. Alright. So we should just move this multiple times. So if it's equal, then we just pop it, right? Because we are trying to find, well, we're trying to pop either the max or we're trying to pop the min. And then we just move the low one by one, right? We move low one by one until we hit the one that is ours, right? And then we pop it. And if the next one does not, like it's good that we don't have to. So basically we say m high if it's equal to monotonic increasing. Actually, no, there's no high. It's just low. This is increasing 0, right? Then we say monotonic increasing dot pop left. And lower plus equal 1. It doesn't matter, right? With low always plus equal 1. And then we always go back up. We'll try. We probably need to also add here. Wow, I look great. Low shall be smaller than len nums. And this. Right? So we do. At the end, low marks the left limit. So we'll say res shall equal to maximum res high minus low plus 1. And at the end, return res. Okay, let's give this one a shot. Yep, looks about right. So monotonic increasing and decreasing, and then we'll pop left based on the current left pointer, right? Because we move the left pointer and we just try to find which one matches. Because if it matches, that means that one can be removed, right? We'll remove it. And everything else shall be removed as well. And the question is, because if you use monotonic increasing, right, to keep the minimum, and you have all the others, you just eliminate all of them, which is fine because now that you're here, you have the minimum, that one dominates, right? That one will dominate on the current. If the current is the minimum, it will dominate, and then you have to go through, you have to basically remove that one, okay, in order to move on, right? In order to move on. And anytime we hit a smallest, or anytime we hit a biggest, that will make things bad. We'll basically stop there, right? We'll stop there. We won't pop that one unless we pop everybody else. So we'll always stop at somebody else, and then yeah, this is a good solution. Yep, this is a good solution. So this is ON solution. Okay, so that one is good. We're done with this. Back to this. So I think last time we got a TLE. It's a very simple solution, but it's not working. I think we need to explore. Either we continue to explore this idea or explore some other idea. So this idea is very straightforward, right? I remember we'll just turn everybody into 0 and 1, All right, we turn everybody into 0 and 1. And then what we want is find the number of subarrays, right? Number of subarrays that fits this. And the reason this doesn't work because we have to go through every single time. So now let's go to the other method that I have. Okay, the other method I have is the count. Okay, it is the count. So I want to get the count on this. So if we do a count, the count to the left of whatever is going to be, so this is always going to be, so we are gonna do, this is gonna be 1 because of a 1. This is going to be 2, right? Because it's 0, 1, 2, right? And this doesn't have because it's consecutive.
And tomorrow morning, can you resend the message to Karina, please?
Yes. Enjoyable sleep and fabulous, lovely tomorrow is amazing and full of energy. That'll be
I think we got scammed.
I hope not. I'll be very, very unhappy. We are. Okay. We have, this will be a 1, this will be a 3, and this will be a 2. Alright, so this is the count. And what we need to do is, starting from this, Right, starting from this, we pick another one. Yeah, we're starting from this. We pick at each position, right? Yeah, starting from this, we find each position will plus 1. Each position will plus 1, right? Because at the end, this is only, only these counts. This is on the other side. So we basically have this position, and we know the length, right? So if we say this is P0, P1, P2, P3, this is P4, right? Let's say the length of it has to be 3. Okay, the length has to be 3. Be 2. Okay, it has to be 2. Then it's gonna be P0 times P2. This plus, right? This times the guys have had 2. And then plus P0 times P4. Right, because you add the length. That will give you 4. And then you do P1 times P3 plus P1 times P5. We don't have P5, so this is no go. And then will be P2 times P4. Right, P2 times P4. And then P3 doesn't have. So yeah, basically this is what we end up with, right? So I was going to say they will only hit once, but if you see this, it not hit once. Basically this is P0 times P2 plus P4, right? P1 times P3, and then P2 times P4. P4 actually happened twice. Now if we do that, so essentially it's going to be P0 times, depending on the because it's modulo, right? It's modulo, so it's going to be pk, the first one, right? Because it's the length, right? The length is going to be k, and then it's modulo plus k, right? Plus p m plus k plus p2m plus k, right? Plus all the way to the last one you can. And then p1 be k plus 1, m plus k plus 1, right? 2m plus k plus 1. And then p2 k plus 2. Now here is where we might overlap. Actually, if we keep going, right, it's for 2, so it will be P6. And this will be also P2 times P6. You see this, we have overlap, right? This we actually overlap, which means if we can find the sum, right, the sum, if we divide things into, k, so yeah, basically we have pk, pk plus m, pk plus 2m, and then have k plus 1, right? Then have k plus 2, until we find something that overlaps. So now we have prefix sum, right, of all these sums. because some of them I only use part of it, right? Prefix sum based on the starting position, right? So we can have k, we have prefix sum 0, 1, 2, and then k plus 1 prefix sum, k plus 2 prefix sum, all the way to k plus m minus 1, right? K plus m minus 1, I have a prefix sum. So I have all these. Then what we do is just p0 times this, p1 times this, and p something, right? P something. So this p something, how do I recognize where it should be? Well, this p something, how do you know? Where does it start? Right here, P3 will do P5, right? P2 will do P5, and P5 will be here. How do we know they match? Well, once we go to mod, right? This is basically mod. This is mod mod m. This is mod m. Wait, hold on. No. Two, we need to find the first. And ideally, if we can yeah, it is. These things mod m, right? P0 mod m is 0. Right? P2 mod m is 0 as well. So this will use the same. And then the first one is P4. P4. So we have something, but we still need to find P4. 4 towards the end. Maybe it will be easier, right, to do a reverse prefix sum, right? So yeah, it is a reverse prefix sum from the back, something towards the end, something towards the end. So we'll find the last one, right? And we record its go front, we record go front. So we'll record everybody's sum. Everyone starts something to the end. Start with something towards the end. Something towards the end. We'll have a prefix sum. And we'll go through this for each one. We find which one we need. And then, okay. That sounds reasonable. That sounds reasonable. But I'm not gonna do it today.